Hello students, welcome to Target IES. This will be your module number 10, a very simple module. काफी simple topic है, stream flow measurement. We measured three things in this chapter. The first thing is stage. Stage यानी the depth of water in your stream. Okay, अगर आपके पास एक stream है, so you have a certain stream. First of all, you have to measure what is the depth of the stream. That is the stage measurement. Second thing is you have to measure what is the velocity of the stream. पानी कितने तेज से जा रहा है stream में. You have to measure the second criteria. Second important thing. First one was stage. Second one was velocity. Once you know this stage, once you know this velocity, what can you calculate? You can calculate the discharge rate. Discharge क्या देता है? The volume of water which has passed the certain cross section in unit time आपको आ जाएगा. Okay, so these three things you measure: stage, velocity and discharge. Okay, अगर आप stage जानते हो, if you know the depth, you know the cross sectional area ना, so you know the cross sectional area. So once you know the cross sectional area, just multiply your velocity A into V. What you'll be getting? You'll be getting discharge. But there are a lot of other techniques to measure discharge. हम डिटेल से पढ़ लेंगे इसी चैप्टर में. ठीक है. Now coming to the first thing, what is that? Stage measurement. What is the stage? The water level surface elevation measured above particular datum. We are calling it as stage. ठीक है. How to measure this stage? There are two types. One is the manual gauge method. Other is the automatic method. What is manual gauge method? सेम है भाई, जो सर्वेइंग में करते हैं ना वही करेंगे. फॉर एग्जाम्पल, इफ यू हैव अ स्ट्रीम लाइक दिस, so wherever you want you can keep your staff. Okay, and you will be getting your reading on your staff. From this staff reading you will know what is the depth of your stream. बात खत्म. Okay, at various points you will be getting what is the depth of your stream. But imagine करना, अगर stream का depth ज्यादा है, is this practical method? If my stream depth is very large, तो क्या आप पानी में जाकर ये स्टैफ मेजर करोगे? इज दैट प्रैक्टिकल? इज दैट इवन प्रैक्टिकल इफ द स्ट्रीम इज लेट्स से लाइक 5 मीटर्स? आप रिवर में मेजर करना चाहते हो, ओके, एंड रिवर का डेप्थ हो गया है मोर देन 5 मीटर्स. क्या ये प्रैक्टिकल है आपको? क्या ये मेथड प्रैक्टिकल है? नो, राइट, इट इज नॉट प्रैक्टिकल. सो दिस इज यूज्ड व्हेन योर डेप्थ इज वेरी स्मॉल. अगर डेप्थ छोटा है, लेट अस से 1 मीटर, then you can usually keep your staff and measure what is the depth of your stream. Okay. Sorry, my voice is little bad because I was suffering from some viral fever for past 5 days. That's why I didn't make any videos. But in the next 2 days, I will be finishing entire hydrology. You can collect videos from Target IES. Okay. The first method was manual gauge, very simple method. Now let us see some important thing. Give it 3 star. Automatic gauge, यहाँ से bit आ सकता है. If there is any bit possible from this topic of stage measurement, that is from automatic stage measurement. ठीक है. So what is the first type of automatic stage measurement? The first one is float type and second one is bubble gauge. Okay, float type gauge and bubble gauge. Now let us see the float type gauge. Very simple concept है. See, let us say there is a stream. Okay, what I am doing is I am constructing a stilling well. क्या है? A still well, or you can say stilling well also, up to you. ठीक है. So what does this still well do? It will have some pipes. Okay, it will have some intake pipes. यहाँ पे water level क्या, for example आप ही बताना, if there is some pipe here, okay, whatever will be the water level, will it be same as the water level here or not? अगर यहाँ पे water level बढ़ेगा तो obviously because of the water pressure some of the water will be entering here and you will be getting the same water pressure here also. Pascal's law समझ गए हो ना? So as if the डेप्थ ऑफ योर फ्लो इज डिक्रीजिंग, यहाँ पे भी क्या हो जाएगा? स्टिल वेल में आपका डेप्थ कमता रहेगा. कॉमन सेंस की बात है. सो वी आर यूजिंग द सेम कॉन्सेप्ट टू मेजर व्हाट इज द डेप्थ ऑफ आवर स्ट्रीम्स. सो व्हाट इज हैपनिंग? देयर विल बी अ फ्लोट. फॉर एग्जांपल, इफ द वाटर लेवल इन द स्ट्रीम इज वेरी लेस, तो आपका फ्लोट कहाँ पे रहेगा? नीचे रहेगा. इफ द वाटर लेवल इज कॉन्स्टेंटली इंक्रीजिंग, तो क्या होगा? दिस फ्लोट विल स्टार्ट टू मूव अपवर्ड्स. ओके, एज द फ्लोट इज मूविंग अपवर्ड्स, this will be connected to a data recorder and ये record कर देगा what is the depth of the present condition of float. ठीक है. So from here you will be knowing what is the depth of water in this particular stream. Okay, and again let us say water level यहाँ पे था. Now water level is again decreasing. Okay, now water level is again decreasing. What will happen to this float? Float again it will come down because here also the water level will be falling. Again the float is coming down. If the float is coming down, again it will be recorded in your data recorder and you will be receiving the data that the water level in the stream has been reduced to so and so units. Okay, things are clear, right? So this is about float type gauge. ये याद रखना, we need an apparatus, we need an entire building for this. एक well चाहिए so that there won't be any disturbance, and this well is called as still well. Okay, you can perform the float type gauge in still well only. Okay, now let us see the second thing, which is bubble gauge. Bubble gauge काफी simple सा technique है. Okay, so first tell me this, you might be knowing, if I have water from fluid mechanics, I know you are a gems in fluid mechanics, right? आप ही बता देना, what will happen to the pressure if I am going down in water? बढ़ेगा कि कमेगा? Your pressure will increase because pressure is equals to WGH, right? So as my height is increasing, what will happen? My pressure is going to increase. Okay, so for example, if I want to pump some air, okay, if I want to pump some air at this small height, मुझे कितना प्रेशर लगाना पड़ेगा? काफी कम प्रेशर लगाना पड़ेगा. Okay, because the pressure exerted on this tube is also very less. But now as I am going down, okay, the H increased. Now if I want to pump some air, मुझे ज्यादा प्रेशर लगाना पड़ेगा because certain amount of pressure is also acting on this tube, right? So if I want to pump something, then obviously I have to apply more pressure. The same concept is used here. The same concept is used here. So in this bubble gauge, what you will have, you will be having one pipe at the bottom of your stream. Okay, at the bottom of your stream there will be one pipe. This pipe will be attached to a air chamber. Air chamber क्या करेगा? Air pump करेगा into this tube. As simple as that. At the same time, this pressure with which this air chamber is pumping ना, वो pressure हम record कर लेंगे. Okay, so for this bubbles to rise, okay, अगर bubbles अब generate करना है तो you have to apply certain amount of pressure, right? If the depth is more, for this bubbles to generate at the larger depth, आपका pressure क्या होगा? You have to apply excess amount of pressure. Okay, if the depth is further increasing, you have to apply even more pressure. Only then the bubbles will be released, right? So you are measuring what is the pressure required for these bubbles to release in this water, and they will come to the top surface, obviously. Okay, so what is happening? If you know what is the pressure at this particular point, we know P is equals to WGH. From here you will be getting what is the height in this stream. Baat khatam. So these are the three methods in which you can measure the stage. What are they? Manual method, just like our surveying. Second one was float type, and third one was our bubble gauge. I hope the things are clear, right? Now let us see how to measure velocity. Now coming to velocity measurement, very simple topic. See, there are two methods in here. The first one is float method. If you want to measure surface velocity, then you can use this float method. लिख लेना यहाँ पे clearly, VS यानी surface velocity. You will be getting only surface velocity. You will not get velocity at any depth. Okay. See, first of all, you have to understand, if you have a stream, right? If you have a stream from fluid mechanics, you already know the velocity profile will be something like this in open channels. याद है ना, फ्रॉम फ्लूइड मैकेनिक्स. सो व्हाट इज हैपनिंग एट द बॉटम, अपना स्ट्रीम वेलोसिटी जो भी है काफी कम रहेगा. एज यू आर ट्रैवलिंग अप, योर वेलोसिटी विल बी वेरी हाई. अग्रीड और नॉट? So in this float method, you are getting only your surface velocity. Okay, you are not getting what is the stream velocity. So what is this float method? Let us try to understand, and then I will explain you how to measure the velocity at whatever depth you want. So for measuring surface velocity, we are using float method, and this is the float method in action. You can clearly see there is a stream like this. Okay, this person, you can clearly see the water is flowing in this direction. Okay, so the person standing here will release one float. Okay, क्या करेगा? He will release one float. So the distance is fixed. आपको दिख रहा है ना? There is a line. Okay, the length is fixed. The length is fixed. ये बंदा क्या कर रहा है? ये बंदे के पास स्टॉप वॉच है, and he is measuring the time required for this float to reach from this point 0 to this point 1. Okay, so now what you know the length आपको पता है, and you know the time the float has taken to reach from this point to this point. So you will be getting what is the velocity, the distance divided by time. वही फॉर्मूला है जो हम लॉजिकल रीजनिंग में यूज करते हैं. You will be getting what is the surface velocity of the stream. Simple technique. I hope the things are clear. So this method is used only when you want surface velocity of stream. It is not used to measure velocity at any certain depth. Okay, and this is possible only in small streams. Okay, this is possible only in small streams. Imagine karna, there is a big river. First of all, you cannot stand like this in big rivers, right? प्रैक्टिकल नहीं है। अगर डेप्थ 5 मीटर है 10 मीटर है तो क्या आप इस तरह ठहर सकते हो? नो राइट। सो ऑब्वियसली यू कैनॉट मेजर द एग्जैक्ट लेंथ ऑल्सो, that is not practical. And if you release the float, it will not, it is no guaranteed that it will flow in the certain direction itself. Okay, variation बहुत ज्यादा हो जाएगा. So it is not practical in measuring larger streams. छोटे छोटे stream में use करते हैं this float method. Okay, so error due to surface wind effect will be very high. Okay, so in general ये जो point है मैं आपको बाद में समझा दूंगा, ये जो point है मैं आपको बाद में समझा दूंगा. ठीक है, ये point कहता है you will be getting the surface velocity, but if you want average velocity of stream, generally we can consider it as some 0.85 to 0.95 of your velocity at this surface of your stream. I will repeat this point again, no worries. Now if you want to measure, if you want to measure velocity at any certain depth, you can use this current meter methods. ठीक है, लिख लेना, clearly लिख लेना. If you want to measure, if you want to measure at any depth you can use this current meter. ठीक है, this current meter is of two types. One is vertical axis meter, second one is horizontal axis meter. Very important bit मैं आपको यहीं पे लिखा रहा हूँ. This vertical axis meter is also called as price current meter. Price current meter, very important bit for state PSC, SSC JE, RRB JE, whatever. एक बिट तो पक्का बनता है, what is price current meter. Okay, if you are writing SSC JE exam काफी दिन चलता है ना, 8 दिन 9 दिन चलता है. Okay, because there will be so many people appearing all over the country, whether you are writing for SSC JE, RRB JE, multiple question papers will be prepared. In one of the question paper this bit will be definitely present. Okay, so what is this price current meter? It is a type of vertical axis meter. So now let us see what is this current meter, how it looks like. So this is the diagram for your current meter. The current meter can be two types. One is vertical axis and other is horizontal axis. अगर किसी current meter का axis vertical है, then we will be calling it as vertical axis current meter. अगर किसी का axis horizontal है, then we will be calling it as horizontal current meter. It can be horizontal axis or vertical axis. Both have different advantages. मैं समझा दूंगा. See what is happening. Let us try to understand. इस तरह से रहेगा. First of all, there will be a boat, or you can stand on station also, you can stand on land also, it doesn't matter, but generally एक boat पे जाएंगे at whatever location you want to measure this velocity. So from this location what you will do is just like fishing, how the people do fishing, right? Fishing net रहता है ना, तो उसी तरह से fishing rod type एक rod रहेगा and you will be dropping this current meter. ठीक है, you are dropping this current meter. ठीक है, so what is happening this, for this current meter there will be a weight attached. weight क्यों attach करते हैं? So that it is not moving here and there. अगर किसी चीज को आप weight attach करोगे तो stable बन जाता है ना, that is why I am adding weight at the bottom. Okay, I am adding some weight at the bottom. इस तरह से कुछ इस shape में रहता है, so we are adding that weight at the bottom so that it will not move side by side. Now what it does, if the velocity of flow, for example if the velocity of flow is less, you can clearly see when some water is passing through this, क्या होगा, this will start rotating. This will, for example this will start rotating like this. Okay, अगर velocity बढ़ा है, velocity of stream is more, then what will happen, this will start rotating at a higher velocity. common sense की बात है. flow आ रहा है, if you are obstructing the flow, obviously it will try to rotate, right? common sense की बात है. the same concept is applied here. so what is happening, it will start rotating with higher velocity. Agreed? So what are you getting? You are getting more rotations in a particular time. Okay, if the velocity is less, your rotations are less. Okay, if the velocity is high, your rotations are high. Okay, using this relationship, if you know what is the rotations, this is recording number of rotations. Okay, it will give you number of rotations in a given minute or given second, it doesn't matter. So once you know this ns value, you will know what is the velocity of stream. Okay, now what is the formula of it? There is a formula. The formula is v is equals to a plus ns plus b. Okay, very important formula, give it 5 star, याद रख लेना, already asked in gate. Okay, so what is the formula? V is equals to a ns plus b. ns what is it? revolutions per second. Okay, revolutions per second. ठीक है, of current meter. current meter कितने revolutions ले रहा है per second, you will be getting from ns. once you know the value of ns, a and b are constants. Okay, a and b are constants, and from here you can get the value of v. As simple as that, right? I hope the things are clear. Now let us see what is this horizontal axis and vertical axis. Let us see what is the advantages and disadvantages. When I'm talking about vertical axis, right, it is not suitable for inclined component of velocity. See, first of all, you have to understand, whenever the water is flowing like this, you can see this is a stream and water is flowing like this. वो हमेशा straight नहीं रहेगा. You know this with practical example, right? So अपने life में आपने बहुत सारे चीज देखे होंगे ना, the stream flowing like this. The ball, if you release exactly right, it will not come exactly at this point. It might reach somewhere here, because there is some inclined velocity component also. Agreed, there will be some inclined velocity component also, therefore the ball will reach in some other direction. Okay, I hope the things are clear, right? So when you are releasing the ball, इसकी कोई guarantee नहीं है कि it will travel in a straight line. It will travel up to its own condition. Okay, the way the velocity is acting. I hope the things are clear, right? इसीलिए float method हम use करते थे small channels में, okay, small streams में, so that the inclined component will be negligible. If you are taking a big river, obviously your inclined component will also increase. Okay, so I hope you can relate this with your general knowledge, right? Now what is happening in this vertical axis current meter? It is not suitable for inclined component of velocity, whereas this horizontal axis opposite, baba, if this is not suitable, it can measure, but it has a limit. It can measure up to 15 degrees. Okay, so if there is up to 15 degrees, no issues, it can measure. Okay, if there is a deviation, or if there is inclined component of velocity up to 15 degrees, no issues, it will give you the correct reading. So it can measure lesser velocities also, but for this horizontal axis there is certain limit. It can measure in the range of 0.15 to 4 meter per second. This is its range, whereas your vertical axis can measure lesser velocities also. And this bit I have already explained. Your vertical axis is also called as price current meter, very important. And the accuracy is up to 1.5%. For example, let us say your velocity is 100 centimeter per second. So the velocity this will measure is around 98.5 to 101.5. Okay, up to 1.5% की accuracy रहेगी, ठीक है? Whereas here in horizontal axis, if velocity is 100 centimeter per second, your velocity will be in the range of 99 to 101. That is the only difference. Okay, so I hope the every concept is covered. Now let us see a very important bit which you have to understand, and many questions come in ESC. Okay, so first of all, the velocity profile is something like this. Velocity profile in your streams is something like this. So what velocity should you consider as velocity of stream, or you can say average velocity? What velocity you should consider? You know, the velocity is more at the surface and the velocity is minimum at your bottom. So in general, if it is a turbulent flow, as we have studied in the float method, your velocity will be taken as 0.85 to 0.95 of your surface velocity. Okay, very important bit, yaad rakhna, this is for turbulent flow, 0.85 to 0.95 of your surface velocity. Okay, but in some conditions he will not mention whether it is turbulent or laminar. He will just give you the shallow stream and deep stream. Then there are two cases. For example, if you have shallow stream and if you have a deep stream. Okay, if you have a deep stream, first आप क्या करोगे? Stage measure करोगे. The depth of water. Let us say if the depth of water is y. Okay, if the depth of water is y, तब आप क्या करोगे? अपना current meter रखोगे at 0.6 of this y meters. Okay, if let us say y is 2 meters, तो आप कहाँ पे रखोगे? Your current meter you will be placing it at 0.6 y, that is around 1.2 meters from the top surface. What are you keeping? You are keeping this current meter and measuring velocity at this point, and that point will be considered as the velocity of stream. 0.6 y from the surface. I hope the things are clear, right? If you read this, if you read my notes, you will be understanding, but ऐसे terms ना आपको confuse हो जाओगे, right? You will not get 100% clear image, but after watching my videos and reading my notes, only then you will be perfect. ओके, सो प्लीज ऐसा मत करना कि नोट्स आ गए सर का क्लास में शिफ्ट मैं बाद में देख लूंगा, आई विल जस्ट रीड द नोट्स. इट विल नॉट हेल्प यू. यू हैव टू वॉच माय वीडियोस, एट द सेम टाइम यू हैव टू रीड माय नोट्स. ओके, नाउ लेट अस सी व्हाट इज हैपनिंग इन द डीप स्ट्रीम्स. द सेम थिंग, द फर्स्ट थिंग you have to measure is your depth. After measuring the depth at 0.2 of your depth and 0.8 of your depth, for example let us say y is 2 meters again, then 0.2 y कितना हो जाएगा? 0.4 meters from the top surface. 0.4 meters एक बार measure कर लेना what is your velocity, and then you shift it to new location. The new location is 0.8 y. 0.8 y यानी 1.6 meters, right? For 2 meters 0.8 into 2, it will be 1.6. So at 1.6 meters from the top surface, again what you have to do, you have to measure the velocity at this particular location. Okay, so you know 0.2y and you know 0.8y ka velocity, v.2y and v.8y. So if you want the velocity in your deep stream, all you have to do is v.2y plus v.8y divided by 2. That will give you your velocity in your deep streams. I hope the things are clear, right? इससे ज्यादा clarity आपको कहीं पे भी नहीं मिलेगा. If you are perfect in whatever I am teaching you, you will be able to answer all the questions in your gate and ESC. That's my guarantee. Now let us see some questions. Okay, so how is the average velocity along the vertical in wide stream is obtained? ओके, इन वाइड स्ट्रीम इसने कुछ नहीं दिया, इसने बस बताया कि स्ट्रीम काफी वाइड है. कॉमन सेंस की बात है, अगर स्ट्रीम काफी ज्यादा वाइड है तो डेप्थ क्या रहेगा, डेप्थ तो कम ही रहेगा ना. इफ डेप्थ इज लेस वी विल बी कॉलिंग इट एज शैलो. ओके, एक कॉमन सेंस आपको लगाना पड़ेगा. ओके, समटाइम्स इन एग्जामिनेशंस फॉर एग्जांपल स्टेट पीएससी हो गया, एसएससी जेई आरआरबी जेई हो गया, डायरेक्टली दे देगा कि शैलो स्ट्रीम. बट इन ईएससी थोड़ा ट्विस्ट करने के लिए इस तरह के क्वेश्चन पूछ सकता है. ओके, बस कॉमन सेंस लगाना, go with your guts, your answer will be 100% correct, because see you are getting one of the best coaching, that is what I am assuring you. So if you are able to answer, if someone is able to answer in India, you will be definitely able to answer these questions. Okay, so you are the best persons in India, so do not compromise. If you have a strong feeling that this answer is correct, go with it, that answer will be correct. Okay, so this question was asked in ESC 2007. What is the answer? By measuring velocity at 0.6 meters below the surface, you will be getting your velocity in your shallow stream. Okay, I hope the things are clear, right? Even if you have doubt, even if you are not sure, just read the options, automatically आ जाएगा. By measuring velocity at 0.1 times the depth of below the surface, ये तो हो ही नहीं सकता, हमने पढ़ा ही नहीं है कुछ इस तरह से. By measuring the velocity at half of the depth, हमने कुछ पढ़ा ही नहीं है. So obviously option A और B में ही रहेगा. By averaging the velocities of 0.2 and 0.8 depth of surface, ये होता है deep में. ओके, ये होता है डीप स्ट्रीम्स में. इफ सम स्ट्रीम इज वेरी वाइड, ऑब्वियसली उसका डेप्थ थोड़ा कम ही होगा, कॉमन सेंस की बात है. सो दिस इज नॉट प्रैक्टिकल एंड ओनली दिस इज अप्लीकेबल. इस तरह से आप ऑड मैन आउट भी कर सकते हो. नाउ लेट अस सी द नेक्स्ट थिंग. अ स्टिलिंग वेल इज रिक्वायर्ड व्हेन अ स्टेज मेजरमेंट इज मेड बाय एम्प्लॉइंग. सो आई हैव क्लियरली एक्सप्लेन व्हेन डू यू यूज दिस स्टिलिंग वेल. मैंने इंपॉर्टेंट नोट भी लिखाया था. फॉर अ फ्लोट गॉज रिगार्डर वी यूज दिस स्टिलिंग वेल. ओके, this question came in ESC 2011. now see this next question, very big question. इतना बड़ा question है, आंसर काफी छोटा है. ऑप्शन देख के आप टिक मार सकते हो, नो नीड टू रीड. 0.2v v.2d plus v.8d divided by 2. यही पढ़ लेना क्वेश्चन, आंसर टिक कर लेना. इन एग्जाम डोंट बी इन हरी, ऑप्शन देख के कभी टिक नहीं करना है. read the question, no issues, because you are getting 2 marks, right? If you are making a mistake in a question, you know you are not losing 2 marks, you are losing 2.66 marks. Don't forget it. Okay, so be careful with your options. Please pay attention in exam hall, because that 3 hours will decide your fate, right? In gate or ESC, that 2.5 or 3 hours, whatever time you are getting, that will decide your fate. So please concentrate whenever you are writing in exam. जब भी आप मॉक टेस्ट दे रहे हो ना, आधे घंटे का भी मॉक टेस्ट हो, गिव विद द टाइम लिमिट, डू नॉट चीट. बहुत सारे लोग मैंने देखा है एग्जाम देते हैं ऑनलाइन का, क्या करते हैं, बुक सामने रखते हैं. दे रेफर ईच एंड एवरी टाइम when they have a doubt in formula, what they do, they open the book, see the answer, see the formula, and then try to solve it. एक मेथड मत फॉलो करना. No one is watching you, so please do not cheat in your test series or whatever exams you are writing. So write frankly or with the knowledge which you have, only then you will excel in examinations. आपको पता चलना चाहिए कि कहाँ पे आप गलती कर रहे हो, only then you can rectify your mistake ना. The first thing in clearing the exam is not attending the correct answers. The first thing is knowing where you are going wrong. Okay, if you know where you are going wrong, there you can work and make the things correct for you. Okay, so see you in the next module, module number 11. Because I have some throat infection, I cannot continue, मुझे थोड़ा break चाहिए. So in the next module we will be seeing what are the methods to measure discharge. Very important topic. ठीक है, so see you in the module number 11.